see what's on TV.
Ooh, math.
We are not watching this.
Hello friends, please welcome my lab partner, my fellow student and math virgin, Penny! Hi Penny. Let's talk about multiplying and dividing radical expressions. The property for multiplying radical expressions is if the nth root of a and the nth root of b are real numbers, then the nth root of a times the nth root of b equals the nth root of a times b. For example, the square root of 16 times the square root of 9 equals 4 times 3, which then equals 12. Also, the square root of 16 times 9 equals the square root of 144, which then equals 12. So it is important to remember that you can only multiply radicals that have the same index, and you have the option of either multiplying before simplifying, like by leaving them together, or by simplifying before multiplying and combining. The property for dividing radical expressions is if the nth root of a and the nth root of b are real numbers and b doesn't equal 0, then the nth root of a divided by the nth root of b equals the nth root of a divided by b. For example, the square root of 36 divided by the square root of 25 equals 6 divided by 5. Also, the square root of 36 divided by 25 equals 6 squared divided by 5 squared, which can be simplified to 6 over 5. So, as seen with multiplying, you have to divide radicals with the same index, and you must make sure that you can combine and then simplify, or you can just simplify before dividing. Another method for dividing radical expressions is rationalizing the denominator so that there are no more radicals in any denominator. Assistant? The first method of rationalizing the denominator can be by multiplying the numerator and the denominator by a number that raises the denominator to the power of the index, which in this case is squared. So then it gets simplified to the square root of 6 over 3. The second method of rationalizing the denominator is multiplying the numerator and the denominator by the same number in the radical of the denominator, so which also simplifies to the square root of 6 over 3.
OMG, did you hear what Sarah did today?
No, what happened?
She cheated on her boyfriend.
What?
Oh no, here she comes now.
Dang, Sarah, back out again with those tripping skills. That place should really fix that ramp. It doesn't even look close to safe. Those builders must know nothing about adding, subtracting radical expressions. All you need is, if the radicand's the same, then you just add and subtract them together. Easy. The ramp only needed the theorem of Pythagoras.
Tiana, stop. You mean the Pythagorean theorem?
I guess. It only needed a squared plus b squared equals c squared. The easiest equation ever, and they messed up on it. The ramp only needs to be 4 feet long and 2 feet high, not 6 feet long and 20,000 feet high. If it was the right measurements, then it would have been 4 squared plus 2 squared, and that would be 16 plus 4. That equals 20. You would just square root the 20 because that's c squared, and you want c by itself, and then there you go, 4.47 feet long for the descending slope of the ramp.
You seriously just did all that because Sarah fell?
I felt it was necessary.
Okay then. I am stronger than the first Jedi. That can't be true.
Wow, Luke should really invest into a new lightsaber. First off, I need you all to use the Force. Focus hard and go within and picture how to do these math steps. Remember all, the numerator is the exponent inside the radical, the denominator is the index, and the base is the radicand. Trooper. Now, Space Cadets, you first must know that compound interest is the combining two Luke's earnings in his original investment. The original equation to find out compound interest is A equals P times 1 plus R divided by N raised to the NT power. A is the earnings Luke has at the end of his compound interest. P would be his starting compound interest. R is the interest rate. N is the amount of compounding occurring in that year, and t is the amount of time calculated during that year. So 500 would be Luke's starting investment, 0.05 would be the interest rate, 2 would be the amount of compounding occurring during that year, and 11 would be the amount of months calculated during that year. So the first thing you would do would be to divide what is seen in the parentheses to simplify down to this number. And then you would add what's here and simplify it down to get 1.025. And then you would take the 11th root and square it to 1.025 and multiply 500 to get Luke's compound interest of $502.25.
Did you seriously just freak out because his lifesaver ran out of juice?
What? In a life or death situation like this, you should always make sure the tank is full.
Whatever.
I'm bored of this movie.
Same.
We need help! We need help!
Here it comes!
Whoa! How did he get there so quick?
Well, I can answer that. We need to use adding and subtracting functions. To add a function, it's fx plus gx. To subtract a function, it's fx minus gx. We can also use multiplying and dividing functions. To multiply a function, it's f times gx. Or we can use fx times gx. For division, it's f divided by g multiplied by x. Or fx over gx. And g can never equal 0. Now on to the flash. If flash is going 4,000 miles per second, then fx equals 4,000x. If the wind speed is 60 miles per second, then gx equals 60x. Now we have to add the functions. fx plus gx equals 4,000x plus 60x. Now we plug in the 2. The 2 stands for the 2 seconds that it takes for the flash to get from Star Labs to the park. So f2 plus g2 equals 4,000 times 2 and 60 times 2. Now we simplify that down, and then we will finally get an answer of f plus gx times 2 equals 8,120 miles per second. Wow, the flash goes faster than a plane!
I'm tired of watching TV.
Well, what do you want to do instead?
Anything else except sitting around. You guys go do that.